Well, thank you, Will. Really interesting panel, and I love that commitment to call to action from all of the speakers. So for me, I think, love the phrase helping to evolve the water stewardship narrative, as well as for another perhaps call is to find your role within the watershed to make sure that you're contributing towards a solution. So now we have, I guess, the middle part of the agenda, where we're looking at the role of digital technologies for healthy watersheds. And really, we have two questions we want to try and get through and answer, and that's how will digital technologies help organizations build and maintain a healthy watershed? And then also looking at the use of real-time information, whether it's really required as part of that phrase that I know, David, you were cautious of using, the democratization of data. So again, throughout the session, please feel free to use the Q&A box, ask any questions, please, whether you agree or even disagree with our speakers. We really encourage you to get your point across. So we have two speakers today for the panel. If we could ask our two speakers to turn on their cameras and microphones, that would be fantastic. I'd like to introduce Newsha Ajami, the Chief Development Officer for Research from Berkeley Lab Earth and Environmental Sciences. Hi, Newsha, and also Stephen Ward, the Senior Manager for Climate Data Science at Deloitte. Stephen, hopefully we can see you and hear you as well.
Yeah, thank you. Thank you, Tom, and I appreciate being here. So thanks for the introduction. Stephen Ward. I have about 25 years of experience in the sustainability sort of research, applied research and translational science space, focusing very heavily on the application and exploitation of remotely sensed data, combining that with in situ measurements and really scaling the study of our sort of natural environments. And so I look forward to the conversation today.
Fantastic. Thank you, Stephen. Well, I think that application of data, and we heard in the previous panel, there's being so much data, but actually making that, applying it at a local level, we're looking forward to hearing from you on that. So for the first point, I've kind of headlined this in my mind as a brave new world. You know, we're seeing a lot of digital developments. It seems every day another digital company is launched or bought or acquired or invested in. So what I want to do on the first part of the session is to kind of find out, by way of an extended introduction, is the kind of the latest project you're working on, and how you're seeing the advances of digital technology playing a part. So Newsha, hi. Let's go to you to kickstart and with that topic in question.
Sure. Hi, Tom. Really delighted to be here. I guess I'm going to, because of limited time we have, I'm going to focus on two things that has been quite revolutionary in recent years. And one of them is all the use of remotely sensed data to better understand our groundwater, which is a very important and essential resource for our communities. And many of communities actually depend on groundwater in arid and semi-arid areas. Up to 70% of our water comes from the groundwater in some parts of the year, or at least some specific years. And a lot of that actually is used on a not very sustainable way, meaning the water, there's not enough time for water to re-infiltrate underground and recharge this groundwater basin. So the digital technologies that have been developed, and the radar and satellite data that has sort of become available in the last decade or so has been quite valuable to first highlight this challenge. Second, to kind of better understand how we can potentially manage what impacts it, how we can reimagine groundwater management, and also help us to better understand how we can use groundwater as potentially a natural storage instead of building surface water storage. There's a lot of movement around repurposing our depleted groundwater basins as a natural storage, especially as some of the Western US, for example, is losing its snowpack as a natural storage, sort of this transitioning to another alternative natural storage as a groundwater basin. Just to tell you two technologies that have been quite instrumental in this process. One is the NSAR, which is sort of like a satellite data, depends on radar technology, that basically helps understand how the change in water storage in a high resolution, both temporal and spatial resolution. Another one is this effort in California, which we are sort of undertaking now, using airborne electromagnetic surveys, which is sort of imagine a helicopter with a massive thing sort of scanning the ground, and I sort of call it the X-ray of underground, which sort of hopefully is going to give us a better sense of different soil layers we have, what kind of groundwater levels do we have, and how we can potentially do all of the above, managing our groundwater more sustainability, using our groundwater basins as a storage, and also being able to minimize the depletion of some of these basins in the long run.
Very good. Well, it was only a few weeks ago on the World Water Day where the theme was actually on groundwater, right? And I think the tagline was making the invisible visible. So arguably, to do that, to make the invisible visible, there needs to be the application of digital tools to get that data to a wider audience exactly on groundwater levels much more quickly and much more efficiently, right? So thank you, Newsha. That's a great introduction in terms of where you're working. But Stephen, let's come to you then in terms of that tagline, a brave new world. Tell us about the kind of current project you're working on and really where that intersects with the developments of digital technologies.
Yeah, absolutely. And I think that it's not just about one project I'm working on. We are having to look across sort of multiple hazards and hazards of place when we're trying to understand risk associated with future development, future investments, and long-term sort of climate changes. And often water is overlooked, right, at the expense of greenhouse gases or the other things that are more relevant or in your face and clear and present in the news and media. So we take great care, and I actually just wrapped up a project where very interestingly, we shifted the mindset of a client's risk over the next 20 to 30 years associated with climate change, away from greenhouse gas impacts or very sort of tangible perils, and to really what was their primary sort of risk in the future, and it was freshwater access in the particular geography that they were working in. The problem with parts of the world that are most vulnerable to water is that they are often the most data poor areas. And so from a surface and visible standpoint, much less the groundwater and understanding the complete dynamics of the water cycle. And so the advent and the advancement of not only the accessibility of these scaled data sources through remote sensing, but really the ability to exploit them is really allowing us as risk planners, us as advisors to organizations around what the future of the world looks like. It's allowing us to provide them with a more complete picture. Remotely sensed data can touch virtually every part of the water cycle now, from clouds, aerosols, vapors, ice, snow, precipitation, all the way through to surface water. And if we're, Newsha mentioned INSAR and IFSAR, the interferometric sort of minute changes in ground levels associated with water or other sort of seismic activity. We're looking at the gravity mapping exercises that are going on at the government level, as well as with the GRACE program through NASA. And these gravity mapping exercises are now able to measure discrete changes in water volumes and provide the ability to estimate, again, at scale. And you're going to hear me talk about this a lot. One of the single biggest problems that we face as scientists when we are trying to address these issues is that the issue is around water is often brought to us as a point source issue from the end user or the one institution that's impacted. getting them to sort of expand their aperture a bit and understand that we have to not look at water problems as a point source problem, but as a broader systems theory or watershed based approach is one of the challenging sort of communication problems that we face. And frankly, data helps tell the story. You know, I always say with remotely sensed imagery is if a picture is worth 1,000 words, then how much are 1,000 pixels worth, right? And I think we need to really understand that there is a layer of, there are many chapters to the environmental story layered within each pixel. And so we need to look at it beyond the surface value of the optical image.
So we need to unpack the pixels and perhaps widen the lens with which we actually view water beyond being a point problem. But you mentioned there the GRACE program from NASA, and we're going to go into a bit more detail on the use of satellite-based data later on. But I think a key phrase that you mentioned was the whole water cycle. And I want to come back to you on this, Newsha, because I think previously from the last decade of writing on the water sector, we've tended to look at the role of digital in different parts, whether it's the water network using data and digital to help find and locate leaks, through to an operational plant level in terms of trying to gain operational improvements. And then you've got the surface water, and we're going to hear from some companies later on in terms of offering real-time data. But actually, when you put all of these different pieces of the puzzle together, in order to link across to the healthy watershed, it's looking at it from a whole watershed, from the whole water cycle level. Perhaps, Newsha, you can comment on how that's kind of linking to the work you're doing.
Actually, maybe such an important point of looking at the system as a whole and at a watershed scale. I would say one missing link that is often overlooked because we find the societal or human side of things quite complex and messy and hard to deal with, is actually understanding demand and how water demand is changing and what kind of information technology needs to be used to sort of get valuable information out of all the data we have from water meters to better see how people are using their water, where they use their water. I mean, if you think about for example, the energy sector, they have this whole slew of solutions and research that has been developed around demand management and understanding loads and understanding when and where people are using their energy. The same exact things can happen in the water sector and actually can help us to better forecast change in the water demand. And if you think about it on an urban water cycle, that is what feeds back into what kind of solutions or what kind of supply do we need to meet the future demands of a community, right? And the general perspective is as population grows, demand grows. As we have more development, we need more water. But actually, if you look at the data across the board, what you see is in developed world, population growth and demand growth has decoupled for at least a number of decades now. And we see a lot more population growth and development, which does not lead into increase in demand. Now, if you go back to utilities who are actually stewards of our waters, like watersheds in some cases, their models constantly tells them demand is going to grow, you need more supplies. So I would say using digital technologies to better understand demand, manage demand, and forecast demand in a better way can actually, in many ways, close this loop. And part of that is actually connecting this whole thing with leaks as well as other parts of the system. But my team has spent the last decade trying to build better tools using sort of all these newer, more advanced technologies and machine learning and data analysis and all that to be able to build better tools to forecast demand, which I think is an essential element of healthy watersheds.
I think that's really important, addressing the demand side of the management as opposed to straight in with additional supply. And I think once you've painted that picture on behavioral patterns on water demand. The next question, I've had some really interesting conversations with water companies on this, is how do you then target different demographics within your watershed to then impact and change human behavior, which arguably is one of the biggest challenges we're facing, right? You can't just drop flyers through the door telling people to stop, to turn the taps off when they're brushing their teeth. You have to go, it's way more sophisticated than that. So yeah, I think that's a really important part of the journey to a digital and healthy watershed, is making sure demand management is addressed as well. But Stephen, let's come to you, because I know you've done some work. We often talk about the residential side on the demand management, but actually the agricultural side. And actually the role of digital technologies is connecting not just between public and private, but between municipal and agricultural water, using 70% of water supplies within a watershed. Surely there's some low-hanging fruit there in terms of improving the water efficiencies within agriculture.
Absolutely, there's improvements available. There are opportunities and there are challenges. And just like thinking about water as an entire system, when we think about agriculture, and it is a heavy user, depending on where you're at, it's using the lion's share of water. Maybe it's challenged by sort of thermoelectric power at times, but the reality is we can do much better. And the benefits or the upside is that farmers globally, they are early adopters of technology. They are willing to adopt change and optimize their operations, as long as they are still allowed a freedom to operate, as long as we're not impacting their yield. So the challenge with dealing with water and irrigation and farming is communicating to the operators, the boots on the ground in agriculture, that it's not going to impact their livelihood. So the way that I like to think about it is most farmers in developed countries get about 40 paychecks in a lifetime. Any decision they make to change technology used on their farm or in their operation is putting one of those 40 paychecks at risk.
Right.
Now, would you do that? No, you're gonna think pretty close and pretty hard about what you're doing. So what satellite imagery has done, and where we've been able, and I've had very practical experience, is really help drive the adoption of variable rate irrigation. Right now, the challenge is that most of our irrigation practices were very crude, and we were putting water onto fields at a stationary rate across the field, regardless of whether or not it needed it. So we've seen a lot of sort of startups now in this space come online that are leveraging satellite imagery to understand the actual sort of evapotranspiration and aligning the satellite data, calibrating it with flux towers and that sort of thing, to ensure that we are getting that variable rate application. The challenge, though, is that we can create variable rate applications from a combination of SAR data or shortwave infrared data from satellites at a very high resolution, 25 centimeters if we wanted to, 30 centimeters. The equipment to apply that variable rate prescription still operates at about 100-foot boom level. Flow-by-flow nozzle control on agricultural equipment only exists in the land of very, very expensive experimental grade irrigation equipment. So we need to shift the conversation away from just the water and the farm and talk about how we can leverage this data to demonstrate and incentivize the equipment companies out there to begin to produce affordable variable rate irrigation equipment for row crop growers that are running in irrigated farms. And I've spent a lot of time in Nebraska, at the University of Nebraska, who you all well may know is heavily involved in the water space in agriculture. And we've been able to demonstrate through in-field experiments and field trials, not only a lift from putting the right amount of water in the right places at the right time, but also a lift in yield associated with not overwatering places. And those generally we saw about a 60% reduction in irrigation volume across these fields, with about a 4 to 7 bushel per acre lift in production. And that was across a couple of the different major row crops. So that's meaningful. If we're approaching that 5 to 7 bushel per acre lift, and then savings on pumping water and electricity savings, it's got a cascading beneficial impact.
When you're talking huge quantities of water, right? 60% saving.
Massive.
There would be water available back into the system for residential, for industry. These are huge savings.
Absolutely.
To make through the application of data, right?
Absolutely. And then we can go so far as we did work with drones and remotely sensed data from drones to, one of the problems is, on the flip side, we've gotten too good at irrigating specialty crops, things like almonds, things like tomatoes, cantaloupes, where now we can irrigate up until the day of harvest. Whereas in the past, we had to stop flood irrigation because the field was too wet to harvest. Now we can drip irrigate all the way up into the time that we harvest tomatoes. Then now we've created a different problem, and we've pushed the problem down the value chain. Now the tomato processor is getting a tomato full of water that then they have to spend significantly more energy to boil out and process the water out of that tomato to leverage it in the products that they're developing. And so the goal there was to understand when to stop irrigation by using remotely sensed data, so that you can optimize the ripening time with a dry down time to get that perfect ratio. We see the same thing in sugarcane, right? The goal there is to optimize the water to sugar content in that plant prior to harvest, so that we limit the amount of energy that has to be expended to get to that raw sugar.
Great stuff. Thank you, Stephen. Well, obviously there's a knock-on impact from having perhaps smarter irrigation, but earlier we talked about the different stakeholders that need to come together to sort of forge this healthy watershed. And clearly, when you're getting data that's that granular and good, you need to sort of make sure it's connected to the actual manufacturers on the ground providing the irrigation equipment. But I found it interesting how you said the farmers were the early adopters, because actually I had a point to raise to both of you, and that's arguably we have a lot of advanced digital tools and satellite-based imagery available, but would you say that the status quo would be one of the biggest bottlenecks in terms of adoption? Because I remember we spoke to some potential customers for one of the vendors offering the solution in the dam monitoring and maintenance space, which arguably is a water reservoir in a part of a healthy watershed. And the phrase that kept coming back was, you can't beat the human eye for accuracy in an industry, I guess, that's relied on manual inspections of teams. But then some of the early adopted utilities are actually combining satellite-based data with their boots on the ground to actually pinpoint where there's a potential anomaly on a 5-kilometer dam. So it was a combination of both. But maybe, Newsha, can you comment on that in terms of overcoming the status quo to adopting digital technologies to drive a healthy watershed?
Sure. I think that you touched on it quite well. The reality is there is a knowledge and belief at the sector level that human knowledge and capacities, has managed to handle a lot of these things for many decades. Potentially they can continue on. I think the reality is that you don't want to get rid of that. You actually want to combine the two, and you want to still have people who have those innate skills to be able to do this without access to digital technologies, but actually using that digital technology to validate their observations, right? That way your next generation is able to do both and combine the two. I would say You touched on dam and reservoir health. I would say there's also this transition on climate-informed reservoir operations, which actually sort of using climate data to understand atmospheric rivers, to be able to manage your reservoir in the right time, to release water ahead of time before you're getting a lot of precipitation. And a lot of that is actually happening in different parts of the country in the US, but actually in California, we have a few reservoirs that are right now being piloted for this. And part of that is because of the climate change. We are getting these like intense events that are bringing lots of rain, lots of precipitation. And we just want to, and conventionally, we were dependent on these rule curves, right? At this time of the year, this is how much you release. At this time of the year, this is how much you release. Because we were expecting certain level of hydrology that would inform that process. And as that hydrology is sort of being impacted due to climate change and the water cycle is sort of impacted in different ways, these kind of climate-informed reservoir operations can help real-time, on-demand sort of management of the reservoirs and making sure we don't end up having reservoir failures or dam failures because of too much water, or making sure you have released enough water that wouldn't cause any harm to your infrastructure, and also sort of creating this very quick expectation of the events that are coming up and how you have to adjust your management based on that. Now, the other side of that, which I think sort of goes back to what Stephen was mentioning, is there are also things to anticipate when you kind of do these kind of using digital technologies. And one of them is, atmospheric rivers, no matter how accurately we expect them, sometimes they can shift a little bit and then pass your reservoir. And then so you have released some of your water and then you may not get as much water as you expect, or something around that line. So it's kind of expecting some of those flaws in this kind of situation is also really important, because obviously digital technologies are useful and important and valuable tools, but we also have to be able to combine that with local knowledge in different ways.
100%. I think that ties back into what David Grant was saying in terms of that local knowledge and empowering with data. And arguably, we need to be able to use the data and digital to help predict the unexpected. Because arguably with climate change changing the environment. But we have a question coming from the audience. We've got a couple of minutes left that I want to go to. But Stephen, perhaps you can just reflect on what Newsha just said in terms of overcoming the status quo and perhaps adopting some of the, because where you're focused is the real advanced side of what satellite data can offer. Right. And you've mentioned there that farmers are actually, they're quite keen to adopt an early adopters. Where else do you see that as a potential bottleneck?
Well, I think there's a couple, right? And I absolutely agree with the earlier statement about the democratization of data. I don't like that statement, because data by itself is no different than, paperweight. If you don't have the ability to exploit it, if you don't have the ability to draw insight from it. A recent study, and I think part of the status quo issue at the moment, there was a recent paper out of the University of Nebraska that showed that only about 7 to 8% of high school students in this country are exposed to earth sciences before they get to university. How do we expect to change the status quo about the behavior and function of the planet when we don't have a fundamental baseline knowledge of how the planet works? And so I always step back to we have to make it easy and digestible, and so I spend a lot of time with scientists around the communication of what we're doing. Right, it's fun to get in a room and talk about spectral diversity and physics and the uncertainty in the models, but at the end of the day, that's not going to move the needle. And so I'm really excited about a lot of the platforms that are coming online. about things like Planetary Engine from Microsoft, you know, some of the Google Earth capabilities, some of the capabilities coming out of the startup space that are making SAR data, which was previously almost, you know, uninterpretable by 99% of the population, making it meaningful and make sense. And so I think it is incumbent upon us as technologists and advisors and scientists to think beyond the data and think about the sort of application of the data. And this is why I'm bullish when it comes to translational sort of science and research. And so it's one of the things that we strive to achieve at Deloitte when we're working with our customers, is to get them to understand the science and enable them to exploit the data.
100%, yeah. The communication and articulating the science to a wider audience shouldn't ever be underestimated. We are drawing this session to a close, but we have one question. Maybe I can throw this to you, Newsha, from John Metzger. Where on the sustainability curve is monitoring and proactive remediation and mitigation in the discussion, research, and application?
That's a great question. The question actually, maybe a different way of asking is, what are we monitoring for exactly, right? And I think depending on which part of the watershed we are looking at, our planet has definitely evolved, and our climate has evolved, and we are definitely facing a lot of new challenges. And a lot of the data collection that we do is very much still sort of rooted in whatever we were used to in the past century. So I would say, depending on where you are, what you're looking at, which part of the watershed, yes, we have a lot more satellite data that's providing and remote data and drones that can give us a lot of valuable information. But in some ways, we are so behind. For example, there are still homes that don't have water meters, right? Or we are building all these new green infrastructure, but we don't even know what we are measuring for, or how does that connect into translating that monitoring into information that can be used in across the board management of these natural infrastructure or green infrastructure. So I think it just depends which part of the landscape you're looking at, but I think the water sector is definitely can benefit from a faster transition to monitoring and digitization and translation of those into the information that can be used for system level management. So that's my perspective on that.
Fantastic. Thank you, Newsha. So accelerating that monitoring phase. Great stuff. Well, we want to thank our two speakers, Stephen Ward and Newsha Ajami. A really great part of the discussion, I think, that sets up the final piece really well.